Hello? Yeah, perfect, it works. So first of all, thank you for coming here to the PharmaTalk. Thank you for Tema, for the organization. I'm always happy here to be in the palace. Very nice locality and good. So my name is Ahmet Ben Abdallah. I'm the area sales director by Korsch, responsible for the MENA countries. And today I would like to share with you, to take you for a short journey about the scale-up of tableting processes from R&D to production. Before that, some word about Korsch. Korsch, a German company based in Berlin since 1919. So we are talking about over 100 years. 100 years of tableting, where we go in our site in Berlin. This is our facilities, so this is the offices. On the back side is the manufacturing building, where we go in with a stainless steel block, and we go out of the tablet press. So all the steps of manufacturing, of assembly, of development are done completely in Berlin, in Germany. Some facts about the company. So the company is a family-owned company. We are around 350 worldwide, 300 based in Berlin, and the rest, some offices in France, in India, in US, Singapore. We have two quality management system. We have like ISO certification, quality management, and so we are producing over 100 tablet press per year. So this year we'll finish hopefully with 112. So 112 machine what was manufactured and shipped will be shipped in 2024. 50% or over 50 active patent today we have. This is a show that we are innovative. We're not selling the technology of the 90s, but we are selling the technology of 2024. So most of the tablet press we're proposing today are being in the market, like the X3 2020, the X5 into 2023. So the new technology and the state of the art. In Turkey, we are too present and cooperating with Tema. Here now over 15 years, I know. So a long story and successful story with Tema. So we have today over 35 machines, working machine in Turkey. So we are present here and we are happy to be here in Istanbul. So which machine we can propose you? We have all the size of machines from R&D tablet press, like the XP1 is a single punch eccentric tablet press. We have a compaction simulator. We'll see a little bit more in details today, the compaction simulation. And the XL100 is, of course, I would say, smallest rotary tablet press, can be used with a different turret, can be used with mixed turrets, so that we can make some R&D development or pilot scale. Production machine, we have all size of tablet press for production machines. We have the X3, XL400, X5, XC600 double-sided rotary tablet press. And you see, for the single-sided tablet press, we have always two models. So the SFV is for the single platform. So the machine was built to manufacture single-layer tablet. And then we have the MFP models. The MFP models is for multifunctional platforms. The machine is flexible and can manufacture, if we take, for example, the XL400, single-layer tablet, bi-layer tablet, three-layer tablet, and tablet and tablet. So with one machine, you have a platform which is, I would say, flexible, and you can manufacture different format of tablet. So all sizes, just an information, for example, the X3 have a 23 station in D. The XC600 have 85 or 65 station in D. So we have all the sizes, and we go till up to 1,400,000, I guess, tablet per hour. So we know to make tablets, standard tablet, and we know to make to containment. So you see, we are not here drawing the pictures of real machines that we have developed the last years. and we supply it in different containment level, OB3, OB4, OB5. So we have now over 25 years of experience in containment. So if you have a project, if you have questions or requirement, please, we have solution, but it will fit exactly to your requirement. We know to make tablet press, and we know to make tablets, and this is important for you. So we have here what we say innovation center or tableting school or labs in Berlin, of course, in our headquarters, and in Boston, US, in India, and in Lyon, where we have pharmacists working, we have technicians working on this lab, and we can make development with you, we can make troubleshooting with you, we can support you, we can compare. You say, okay, we have another brand, we want to see how our product will work on Korsch. You are always welcome in Berlin or in the world, and to show you our know-how and to share with you our know-how. So, the theme of today is scale up from Compaction processes. So, from where we go and where we want to come. So, our goal is to develop something in L&D and to set the process parameter and to use exactly this process parameter in production in a robust and reproducible processes. So we want to develop something in a small scale and take exactly this parameter and bring it to production machine to get the end product in the end, the tablet, within the specification. So as always, our focus is the tablet, and the tablet must be within the specification. So when we are talking about tablet within specification, what we are talking about first the tablet shape. It means the tablet must be the weight, the hardness, the thickness, the diameters is fixed by the format. Two is important, the other specification like flowability, dissolution, uniformity of the API. So this is we have to take always in our focus the tablet and how we can develop a process to achieve this tablet within the specification. Okay, so we have a tablet and we have a tablet press. So which impact or which parameter have impact on my tablet specification? So we have to understand how the tablet press is working first, to understand or to fix which parameter have an influence on my tablet. So this is compression process. We have a feeder with a filling, a dosing, it means fix the weight of the tablet, pre-compression, main compression, and ejections. I have a video that I would like to start so we see a little bit more in details the process. This is the XL 400. So we have the filling of the powder, we have here the feeder. The feeder, of course, have 284 millimeters of filling length, so we give the time to the powder to go into the dye. So the first step is always overfilling, the filling step. Then we have the dosing. It means we maintain in the dye the quantity of powders, but to give us the tablet weight. Then we go to the pre-compression. So this is the pre-compression cycle. So that we take off the air of the powders, we put the particle in position. And you see by Korsch we have here a dwell bar that will maintain or extend the compression times, main compression, and then ejection for the tablet. And with the compression force, we can find out or see if a tablet is within the specification or outside of the specification. Okay? Perfect. Good. So, taking consideration of a process, so which parameter okay, it's working. Perfect, thank you. So, which parameter have influence on my tablet? So, the two parameters we will take in consideration in this presentation is the compression force and the dwell time. The dwell time is the time, the compression times, but the compression force is over 90% of a maximum compression force. So, two parameters that we will take in consideration in this presentation is the compression force and the dwell time. So what is the impact of this compression parameter on my tablet? My focus always to get the tablet within specification. So the compression force, theoretically, when I increase the compression force, here we take the hardness as an example. One specification of the tablet is when the compression force increase, theoretically, the hardness of the tablets increase, if I have a good formulation. Sometimes the compression force increase, the hardness increase, but I get a plateau. I cannot go over a hardness that I wish. Or sometimes I have capping, so the hardness increase and then it drops down after a compression force. So there's a link or a direct relation between compression force and hardness. The next point that have impact on my tablet specification is the dwell time. Dwell time is too depending on, of course, the tooling format or the tablet format and on the turret speed. So higher speed, shorter dwell time have to influence on the tablet hardness. The next point that we have to take in consideration as we are doing R&D development, so I start on small tablet press and going to production tablet press, so the turret size will change. When the turret changes, so the diameters of the turret change will be higher. A higher diameter means a higher tip speed. Higher tip speed means a shorter dwell time. So I have compression force, I have the dwell time, and have the size of the tablet press have an impact. Whatever I'm working, for example, a B or D tooling, I have a different dwell time, I have a different compression time. So how I proceed to make a development. So development, we start first with R&D tablet press or R&D equipment, like the eccentric tablet press, like compression simulators, like a rotary tablet press. And when I do a scale-up, I need to do it in different steps. So the different step, normally we start with hydraulic press, then we go to eccentric tablet press, then we go to rotary tablet press, R&D, then we go to production. Why we need a different step to go from the lab scale to production? Because the process and the compression cycle is different. If I take eccentric tablet press, we most use it in R&D department, the eccentric tablet press, we have only the upper punch who's moving. So the compression is done only for upper punch. And the dwell time, because eccentric is going down, pressing, and then eccentric going up. So the dwell time in eccentric tablet press is much different as in rotary tablet press. So if I develop here, I cannot transfer directly to a rotary tablet press, so I have to make always in-between steps from eccentric to small rotary tablet press to production tablet press. To the speed of an eccentric tablet press, I cannot control it, so I cannot make a direct transfer. We have a solution for you. It's the Steel One Evo, is a compaction simulators that give us the possibility to make in one step development, finding out the recipe, and going to production machine. So how we can do that? So first we have to understand how it works. So a compaction simulator is a single punch tablet press, but is not eccentric. We can control the speed of the upper punch and the lower punch, and we can control the acceleration of a lower punch so that we can simulate the feeling, the dosing, the pre-compression, the main compression, so that we have exactly the same cycle of compression as a rotary tablet press. Here an example. So this is a profile, and today we have a nano with us, so we can show you a little bit more in detail. So please don't hesitate to reach us or to contact us if you want to see a demo or to see how the machine is running a little bit more in details. But here we have The green one is the movement of the lower punch. So we have here the feeling. Then we have the dosing, pre-compression, main compression, and ejection. So the movement of the lower punch. And we have here the indication of the pre-compression, of the main compression, and of the ejection. So we have an indication about the different parameters, the different process parameter, and we can soon find out what is the dwell time. So we can find out the compression force, pre-compression force, all the process parameter on the Steel 1 Evo. So here a case study that we have done in our lab in this single step of scale-up of the process, starting from the Evo and going to the production machine, the X3 here in details. So what we want to do, or what is our aim in this study, is first to make the development, so to make the material characterization and fix which recipe parameters, then take this recipe and put it on a production machine and find out if the process are running robust, reproducible, and we get the same tablet. Our target always to get the tablet within specification. So which product we use? So we make the case study with two different products with tricalcium citrate. One is for excipient for direct compression with TB, and one a supplement, and we have add a magnesium stearate. So we have two products that we use, one for direct compression and one with a magnesium stearate to optimize the flowability of product. So the first thing what we have to do for the study is first to find out at which compression force we have to run the process. So here we made a product characterization. So the compression force, and we link it the compression force to the hardness. In development, we don't use the hardness as endpoint. We use most of the time the tensile strength. The tensile strength is the same as the hardness, but we divide it by the surface. So it gives us the flexibility. We develop something. We don't have to take care about the format. We can use B, D, round tablet, shaped tablet. This can be done in the later stage. So the tensile strength, we always recommend that it be over 1.5. 1.5, that it gives us the possibility to handle this tablet for coating machine or for blister machine. So we have enough stable tablet for handling. So we see here the orange one is for the direct compression product, and the blue one for product where we add magnesium stearate. And we see when we add magnesium stearate, we drop down a little bit the hardness. If we want to have over 1.5, so we are around 80 kilonewton. We can use 100 kilonewton, but our aim is always not to use the maximum speed. We want that the machine running stable, the machine run with low compression force, so less wear and stable for over the next 20 years. So the compression force, okay, we will take the compression force around 18 kilonewton. The next point what we have to find out, at what speed we can run the machine. And we know that compression force, dwell time, is having an impact on the hardness. So we see here the first product both of them are not very sensitive to dwell time, so they don't drop very quickly when the tablet speed is increased. So we have a tablet speed, and here we have a hardness of a tensile. So we see that they don't drop very quickly. So this product is a good product, and we can use at the maximum speed of a tablet if it's wished. We recommend always to go to 75 or 80% at maximum speed. So we found out the process parameters, so which compression force it means, which is the insertion depth, which is the tablet thickness, which is the filling, dosing, and so on. So we fix our parameter, and then we bring this recipe, what we have developed, we put on our X3, our production machine, and we run it as a long run, so 20 minutes, and to find out what the compression force is stable. It means we are well filling the product, so we don't have any product of filling, and the result of a product. So we have the green is tablet weight, is we achieved the target tablet weight, and we achieved the target tablet hardness. So what we developed on the R&D, we bring it to production, and we get it for the first product, so a direct compression product, and for the mix with the magnesium cerate, we achieved the same result with the same parameter that we set on the R&D tablet press. So in one step, we could achieve the product. This is the specification. So this is a comparison between the result of a tablet with weight and what we achieved on the production machine. We don't have any significant deviation between what we have developed and what we have achieved on the production machine. If now we compare the recipe, and this is our aim, is to fix a recipe in R&D stage and to compare the recipe that bring us the same tablet specification on production machine. So when we have here the comparison between this, the deviation, we see that we have nearly or exactly the same process parameter except two parameters which is different. The first parameter was the filling, the dosing here. So on the EVO is 6.97 and on the production tablet press 8.8, which is normal. It's normal because we run the process on an EVO with a feeder, but we can control the filling time. So we are talking about 1 second of filling. And in a rotary tablet press, we have a tablet press is rotating. The filling is very short, so we have to increase the dosing to achieve the product weight. The next point is the difference is here the edge thickness. It means the distance between the upper and lower punch to bring us or to bring us the tablet hardnesses. We have here a deviation. We have a deviation because the simulator, we have a possibility to calculate and to find out the deformation of the punches. When we make compression, the punches are deformation there, and for the Steel 1 EVO, we have a possibility to find out this value and take it in consideration during the compression. So the result of it, we developed something on the simulation on R&D scales, and we could transfer it to production machine one-to-one, so it works, and we could do it in a single step. The only, I would say, small difference is that the filling can be estimated on a simulation, as we have a different feeder with different, so the filling step as a rotary tablet press. So this is the presentation around scale-up, and now comes the, I don't know, it's a funny questions, but I hope you get coffee today in the morning. So the question, and you can win something in the end. So as a long text. So we have a tablet pharma as a company who are producing a 12 millimeters round convex tablet with a brake line on a Korsch X3 with a D turret. So you can scan with your mobile phone the QR code. So the question comes in Turkish, and then you can answer the question. So please scan it because so you have it in Turkish. Yeah, okay, the question is there. So perfect. So you can scan it and then you can answer it. So yeah, the question is running. Yes, in mathematics. I hope you get your coffee or your tea in the morning to be able. So this is a good productivity question. We have a tablet of 13 millimeters, but running on D turret, 25th station. We can just, by changing the format, changing the turret to 34, and we can increase our productivity by, you have to find out how much boxes per year. Good. So I come to end time. Thank you very much for your attention. And if you have questions, with a pleasure, so we can answer. We are all the day with you. So please, during the coffee break, tea break, lunch, don't hesitate to talk to us. And we have the simulations. We have the Nano today, so it's a good opportunity to show you that. Thank you very much.